Welcome to my presentation. In this presentation, let us see how we can perform multiplication of matrices. Let us define what matrix multiplication is. Matrix multiplication can be performed if we have a matrix A as equal to Aij, elements Aij in them, and if this is a M by N matrix, and if B is another matrix which has elements Bij in them, and it also is of size N by P, then we can write the product of these two matrices as follows. We can write it as matrix A times matrix B is equal to Cij. This is going to be another matrix which will result out of that. It will be another matrix which will result out of that. One easy way to see whether matrix multiplication is possible or not possible is by looking at looking at the size of the matrix. What do I mean by that? Let me explain that. If A is a matrix, let's say if A is a matrix and if this has M by N size to it, and if we have another matrix B like that, and if this matrix has size N by P like that, in here the thing to remember here is as long as and then in here I want to just point out that the first letter or the first term is always the rows and the second one is always the columns. The first one is always the rows, the second one is always represents the columns. So one thing to remember in here is as long as the number of columns is equal to the number of columns in the first matrix is equal to the number of rows in the second column. So if n is equal to n, or the number of rows is equal to the number of columns in the first and second matrix, then we can determine the size. Then we can determine the size of the matrix as follows. We're going to look at the number on the row on the first matrix and the number on the column on the second matrix, and we're going to pick this one as the size. The size of the matrix could be read out as M by P matrix. So once again, if the number of columns is equal to the number of rows, number of columns in the first matrix is equal to the number of rows in the second matrix, then the size of the matrix can be determined as M, the number of rows in the first column, and then the number of columns in the second matrix. So that is the way we can think about it. So let me explain this with a simple example. Let's take an example here, and then in this example, if A is a matrix and if this has elements like this, -1, 3, 4, -2, 5, 0, like that, and if B is another matrix and then this has elements -3, 2, -4, 1, like that, and then if we want to find the product AB like that, we can do the following things. Step number one, we want to first recognize the size of matrix A and the size of matrix B. What is the size of matrix A? It has 3 rows. And 2 columns. And what is the size of the second matrix? It has 2 rows and 2 columns. And then we said if the number of columns, if these two numbers are the same, if the number of rows, the number of columns is equal to the number of rows, then the size of the matrix is going to be these numbers. The size of the matrix is going to be 3 by 2. We know now the dimension of the matrix. It is just a matter of executing now. So we're going to just multiply these numbers out and see what we get. Okay, so let us do that in step number 2. Step 2. In step 2, we're going to perform the multiplication process. So let me write this step one more time, and then we will multiply it out. The two matrices we have is -1, 3, 4, -2, and then 5, 0. And then the second matrix we have is -3, 2, -4, 1. This is what we have. So the way to multiply them out is, by the way, this is matrix A and this is matrix B. This is matrix B. So the product of matrix A and B is going to be as follows. The way we do that is as follows. We take the first row, we take this row and then multiply to the corresponding we take the row from the first elements of the row of the first matrix, multiply to the corresponding elements of the second matrix of the column of the second matrix, like this. So -1 times -3, and then plus 3 times -4. That is the first location of the product matrix. And then we take the first row and then multiply to the second column, like that. And then we exhaust, then we come to the second row, then we come to the third row, and then write them out as in that order. So the second part of this product matrix is going to be as follows: -1 times 2 plus 3 times 1, like that. We got the first row exhausted. Then we go to the second row and then multiply to the first column and multiply to the second column and then write it out in that second row format. So 4 times -3 plus -2 times -4. Then 4 times 2 plus -2 times 1. We've exhausted the second row, multiplying by the corresponding columns of the second matrix. Then we go to the third row in here and then do the same thing. 5 times -3 plus 0 times -4, and then we take 5 times 2 plus 2, 5 times 2. Let me write this a little bit more clear. 5 times 2, like that, and then 0 times 1. So we got all the elements. It is just a matter of simplifying these. When we simplify these, what do we get? This is the numbers we get. This is going to simplify as follows. I'm going to write it a little more. -1 times -3 is +3, plus -3, 3 times -4 is -12, right? And then in here we have -1 times 2 is -2, and then 3 times 1 is 3. In here 4 times -3 is -12, and then plus 4 times 2 is 8, and then in here we have 8 minus 2, and then 5 times 3 is negative 15, and then this goes to 0, therefore that is going to be plus 0. 5 times 2 is 10, and then this goes to 0, therefore plus 0. When we simplify this simplifies to 3 minus 12 is negative 9, and then negative 2 plus 3 is 1. Negative 12 plus 8 is negative 4. 8 minus 2 is 6. Negative 15 plus 0 is negative 15, and then 10 plus 0 is 10. So this is the way we can this is the way we perform the multiplication of two matrices. So in my next presentation we shall look at some more examples related to multiplication of matrices.